Hi, this is Kyle Jensen, and I'm asking for you to please take a few minutes to watch this presentation about my new company, Planktonic Resources. Planktonic is a startup with a very important mission, cleaning surface water at a grand scale while sequestering carbon at a very significant rate. Thanks for your time. It's only about 15 minutes. I really appreciate it, and I know you'll find it worth your while. Good morning. This is Kyle Jensen, and this presentation will show how we can vastly improve surface water quality and sustainably sequester carbon with the same method. I really believe, since the technology exists, it's a cultural hurdle. This brings to mind the movie Quest for Fire from the 80s. It's extraordinary because it shows primitive humans that cannot recognize their resources or their potential, that have inadequate social and governing structure, and they're challenged to collectively work together on goals that can benefit their clan. Recognizing our resources, communicating and working towards a solution means seeing our massive planktonic algal stands that are occurring in hypereutrophic lakes as resources, and understanding that when we release that water to higher quality receiving waters, that water gets degraded significantly. We also need to make sure we keep in mind that filtration systems that produce high clarity clean water and a rich, wet, fertile biomass side stream exist. These are non-chemical treatment systems that are very effective at large scale. The coagulation of phytoplankton in surface water is usually done through either adding a chemical reagent or electricity. And these two methods disrupt the surface charge on the outside of the algal cell and makes them come together in this slurry that you see at the bottom of this photo. So using flotation, you can have a solids concentration in the 3% range, and with settling this phytoplankton out, you can routinely produce a biomass stream in the 1% solids range. But with the electrocoagulation, we must physically oxygenate the outflow because the electrocoagulation process completely degasses water. Electrocoagulation is a wonderful technology, but it requires a lot of power. In this case, we need to generate that from solar power. To give you an idea, 1 megawatt of articulated solar panels will require 3,000 solar panels of 320 watts each. That covers about 5 acres and costs about $1.5 million. So this type of system in multiples would be required for a large electrocoagulation filter that removes phytoplankton at the scale of lakes and rivers. So if we want to take a deep dive into the effectiveness of electrocoagulation, you can look at the study done by Rupert Craggs, one of my first postdocs, and his associate Jason Park. They tested electrocoagulation on mid to high suspended solid wastewaters from an advanced integrated pond system. And these graphs show you the kind of performance that you get with 90% removal of suspended solids, BOD, and total phosphorus at 95% removal. So this is a very effective technology that has been around for 50 years or more and works very well without added chemistry. It does use chemistry in the sense that there are consumable iron or steel plates that the current is applied through to the water, and those have to be changed about once a year. So technically you're using iron here, Fe, but we're not adding polymers or ferric chloride, salts, anything of that nature. So after this electrocoagulation system removes phytoplankton from the surface water, it's really important that we use this harvested biomass in its wet state, it takes way too much equipment and energy to dry it out. And if we don't use it right away, then it can smell and become something that you don't want to deal with. But if we use it effectively right away, then we can make good use of this biomass. One bamboo species that is particularly interesting to us at this point is Phyllostaceus heterocladia. Bamboo has a rare characteristic of being able to do pretty well even in standing water. So if we were to flood irrigate bamboo and put this material over a large area and then we got a rain event, this particular bamboo wouldn't be as sensitive to having wet feet, as they call it in the bamboo industry. There are other species to grow as well. Agricultural management and the fine grading of the soil in the area of the plants is really crucially important to making sure that they get just the right amount of irrigation and fertilization and not too much. And here's a little bit more specific data on heterocladia. One of the things that I'll point out here is pH is very important. Heterocladia is pegged out here at the 4.5 to 7.5 range. When you apply algal biomass to soil, it can tend to get alkaline. And so one of the important things that Planktonic is going to be involved in researching is setting the parameters of how much this material we can add and making sure that we don't get excessive alkalinity in soils. So there are many different species of algae, obviously. Speciation varies in surface water by location, season, and just over time. And that's one of the primary focuses of Planktonic Resources, is to collect these algal species and as they grow wild, and then research and test and optimize their performance as agronomic fertilizers, delivering more than just macro fertilizers, but also micronutrients and other constituents like plant hormones and enzymes and fungi, etc. So flood irrigating planktonic algae onto terrestrial crops, as well as broadcasting the algal slurry onto crops, is nothing new. There is a kelp-based fertilizer being manufactured right now as a foliar spray. That's a highly processed, very specially processed algae. But there's also another specific algal species that is being cultured, very similar to the planktonic algae, and then they're refining that and using that as an agronomic fertilizer. But the benefits are really well known for this kind of aquatic plant fertilizer. Not only do you get nutrients in the fertilizer, but you get 4 types of plant hormones, and you get non-nitrogen organic matter that helps hold water, trace minerals like calcium, potassium, magnesium, and the others, up to 70 minerals, vitamins, and enzymes. All do very important things like promote additional budding, extend the shelf life of produce. They increase nutrient uptake and protein content of crops. Resistance to disease improves. Resistance to insect stress improves. You see more vigorous growth. There's just so many advantages that it's really worth looking into further. And the various species that we harvest from surface water have all of the attributes that these two kelp and cultured algal products have, but nobody's really researched that, and that's one of the primary goals of Planktonic Resources. So here you see a specific planktonic algal species being cultured in a raceway system, real similar to the one that Oswald developed. And so this is probably not one species, but probably a group of 2 or 3 because you get weed species that come in from outside. But this particular company harvests this algae. They process it, with change in pH, and it has shown to have many benefits for crops in the field. So planktonic resources will rebuild our deteriorating soil bank, and it will do so largely by adding biological material to depleted soils. A lot of people don't know that a third of the carbon dioxide that a plant takes up goes through the leaves, down the stem, into the roots, out of the roots to feed mycorrhizal fungi, these little white hairs that you see in this graphic. And these mycorrhizal fungi grow throughout healthy soil. They use that carbon dioxide as a metabolite, and they also digest constituents and compounds and minerals that are in the soil, and the term is called chelation. They make available or chelate these nutrients in the soil, and then the plant roots can absorb them back up again. So obviously you can see how using a fungicide on soil really damages its ability to support plant growth. And what we add as this live harvested algal material is just loaded with beneficial bacteria and fungi and other organisms that add to soil health through their biological behavior and their biological function. So this is Planktonic Resources' first 10-acre bamboo plantation, bamboo farm. And you can see that it's very conveniently, it's in the upper left-hand corner, and you can see it's conveniently located adjacent a canal, which fortuitously has lots of plankton-laden agricultural tailwater in it. We plan on using this particular plankton to start our studies, but our plankton removal filtration system will be trailer-based, operate off of solar systems, and we'll be able to pull it around and place it in various locations adjacent plankton-laden surface water where we want to study the specific mix of plankton with respect to how well we can use it as an agronomic product for both fertilizer and irrigation. So the idea of using bamboo to sequester carbon is not new. It's a popular idea, but it does have its skeptics, and it ranges, as shown here. Some people feel that bamboo sequester 2 to 6 times more carbon than a forest of trees, and then there are people that have tested bamboo and found that CO2 coming out of the plant can be very high and can potentially negate their uptake. But working in our favor, we have much more data on how bamboo do sequester carbon than conflicting data that show anything that would lead us to believe that it was going to be a net producer of carbon. Here is data over 100 years of bamboo and how much carbon it sequestered, and you can read the numbers. And this is just one of many sources that talk about carbon sequestration with bamboo. So here's some work out of Singapore that takes a look at 70 species across 22 genera of bamboo and estimates the carbon accumulation rate. And they have above ground between 16 and 128 metric tons per hectare, and below ground 8 to 64 metric tons per hectare. And in red, their annual accumulation rate they found was between 1 and 14 metric tons per acre for the species that they looked at. So here's some work out of East India from Suresh Singh, and he showed, after looking into the northeastern hilly states of India, and studied 90 bamboo species, and he found a one called Guadua augustifolia that was capable and measured to sequester 100 metric tons of carbon in its above ground biomass. The U.S. cement production is about 90 metric tons per year. That means that culturing a Guadua augustifolia could sequester the entire footprint of the cement industry on the area about half the size of the Everglades, which is also about equal to what we have in the United States in corn production. Now, of course, to keep this carbon sequestered in bamboo, we got to pay attention to what we're doing with it. But there are many uses that sequester carbon through bamboo and last for a very long time, if not indefinitely. Here's a guy making furniture out of bamboo. That's his whole company's carbon negative through that. Now, we've also got the textiles made out of bamboo, which are really popular. Maybe a little bit less durable carbon sequestration there. We can make lumber with bamboo, at least the poles, and that is a direct substitution for wood construction. It's actually stronger than wood and has a lot of other very great benefits. And then if you want to sequester bamboo permanently, we can take the scraps and we can heat them up in the absence of oxygen and make biochar. We can use biochar for water filtration systems, or we can bury it in the ground, which is literally like mining coal in reverse. Those resources stay locked up eternally. Yeah, so pyrolysis is a really wonderful process, and biochar, so useful. It makes a huge difference in if used as a fertilizer for growing crops because it harbors beneficial bacteria. Bamboo can be made in a really environmental way by using the heat of the sun, focused on very simple enclosures that take syngas off and also collect liquid residuals, which can also be manufactured into other fuel products or plastics or otherwise used. And this is the ultimate in carbon storage. We just couldn't ask for a more permanent method that's so available with just the energy of the sun and simple fabrications. So solar thermal conversion of biomass through pyrolysis is an option for storing energy in liquid, gas, and solid form. This work that was done in India, I think, is showing that they got efficiencies in the 68 range with 51% oil, 43% char solid, and 4.8% non-condensing gases while conducting pyrolysis on bamboo. So this data was very encouraging and shows that a solar pyrolysis approach can be a very economical solution for carbon sequestration. And so I guess it's obvious that I feel like we really ought to be paying attention to this. If we can't agree to use our resources to benefit our environment, this is really us. And we need to advance our civilization to the point where we can use the tools and we can observe our resources and be a little bit more careful about how much carbon the practice of life puts into the atmosphere. Thanks for listening to my presentation, and I'm always available for questions. My name's all over this presentation, and of course you're welcome to call me or email me with any questions you might have. Thanks.